Hey people, let's talk about black holes today. Now, this is a star. Inside, in the core of the star, there is nuclear fission taking place. All the hydrogen atom, due to intense temperature and pressure inside the core, they are combining to form helium. When this helium is formed, some energy and pressure is released from the core. This energy pressure, it cancels all the forces from gravity outside, and thus it leads to the shape of the star almost same. Now, there, what if there is a situation when this fuel from inside it starts to decrease? After a point, it will end. Nothing is infinite. The gravity from outside will be dominant here, and it will start pushing it inside. This will happen in case of stars that are very big. To compare it, at least three times bigger than our own sun, because not all stars become black hole. Some either become white dwarf or red giants, and there are others also. So a star has to be big enough to become a black hole. All the pressure from outside, gravitational force, it will start to decrease the size, and it will continue decreasing. Now, the matter of the sun isn't being destroyed, or it is not being scattered. All this matter is being also shrinked too. At a point, it will become a point. The gravity from outside will be so high that it will be crushing itself at the atomic and subatomic level. Now, remember that all this mass from this star is also in this singular point, which means that density has increased. Why? Density is mass by volume. In this case, the mass is same. Mass is not being scattered or destroyed, so it is same. Which means that density here is inversely proportional to volume. Less volume means more density, and it is infinitely small, so the density is infinitely more. This density being infinitely more means that space-time is being bent infinitely. It is what we call singularity. At singularity, space and time come to a stop. Time doesn't work. Space-time bends infinitely, and not even light can escape it. It is basically a huge amount of mass compressed into a very small space like this dot. This dot is singularity, and it is present in between every black hole. Every single black hole has a singularity in a black hole because it's infinitely dense, so all the lights that come in never escapes. It doesn't escape from the black hole, and thus we also call it black. But there is some energy that radiates out, some energy and radiation that is coming out of the black hole, that is called Hawking's radiation. This also shows that after a time the black hole is continuously releasing energy and radiation. So at a point, all the energy and radiation will end, and the black hole will vanish. This also supports the theory of Big Crunch, which is like opposite of Big Bang. Since some energy and radiation is being thrown out of the black hole, we will see that the black hole is not completely black, but it is glowing. It is glowing red. You can also see one of the first pictures of black hole taken in 2019, that it is glowing. That's how we were able to detect black holes. There were First we were able to detect it by the gravitational field, and the second way is this radiation that is being thrown out, the red glow, through which we were able to take its first picture. This is all the basics about black hole. Thank you.